Hey guys, I just wanted to walk you through a few problems solving the problems with the Pythagorean theorem, because I know it's maybe a little new to some folks who haven't worked with this type of problem before. Pythagorean theorem is for solving problems with right triangles. Right triangles have a right angle, obviously, and so the formula looks something like this: a squared plus b squared equals c squared. And that's something you probably remember even if you didn't remember how to use it. C is a special side. That's the side that's opposite of the right angle. And since the biggest angle in a triangle is 90 degrees, that's always going to be opposite of the biggest side of a right triangle, which you, of course, remember is called the hypotenuse. So that's what C is, and you'll see C is all by itself on this side of the equation. The hypotenuse, if I'm writing my formula like this, C's the biggest side is going to be by itself. And so if I'm looking for A is my variable. I'm going to leave that alone. B in this case is going to be 9, so I got 9 squared equals. C in this case is 15, so I've got 15 squared. I'm just substituting in the numbers that I know. Easy enough. And so you can punch these in your calculator, or you can remember that 9 squared is 81, and 15 squared is 225. And then I bring down my plus a squared. And now it's just for right now, a simple algebraic equation. I can subtract 81 from both sides of the equation. Let me just check my math real quick. Easy. A squared is equal to 144. Now, for some reason, this is always the step that trips folks up. They're used to solving simple linear equations, and they see that 2 and they think it means 2 times A, and they divide both sides by 2. And you all are too smart for that. You guys know that this is A squared. And just, a brief aside, we know A squared is not 2 times A, but it means A multiplied by itself. So I've got 2 A's being multiplied together. And so the opposite of squaring something is the square root. So if I take the square root of A squared, that's just going to give me A by itself. And so what we call this is an inverse. The square root is the inverse of the square. It kind of undoes the square. And some of y'all have taken some more math, kind of know there's a few more complications than that, but for right now that's all we need since we've got nice positive numbers. So if I square root both sides of the equation, the square root and the square, they're inverses. I like to think of them as canceling each other out, just like 81 minus 81 cancels each other out. That leaves me with A. And again, punch this in your calculator. It's just going to give you a number. But in this case, we hopefully remember what that number is. The square root of 144 is 12. And so here, I've used the Pythagorean theorem to solve for this missing side of the equation, which is what this formula lets us do. Now, this is just a simple example. You've probably seen a dozen of these if you've taken geometry especially. What we're looking to do with the Pythagorean theorem is to calculate our material usage when we're building a crane boom. And so here, you've probably got some kind of truss structure for your crane that you're trying to design. What I need to know before we can actually start building this particular design is, do I have enough material to actually build it? And so in order to figure that out, I'm going to need to know how much material is accounted for in each of these members of this thing I'm building. And so you can do some measurements. It's going to be a piece of cake. And so maybe what I know is I've got, some of these pieces I've already cut, I already know the length of. And I'm trying to figure out, for example, if this height is 10 centimeters and this width here is 15 centimeters, how long do I need to cut that diagonal there? And so this is where the Pythagorean theorem will come into play. And for a lot of these truss structures, it's broken up into right triangles. And so it may look kind of complicated, especially if the Pythagorean theorem is something that's required a little bit of refreshing on your part. But all we're doing is trying to take this thing and break it down into right triangles. There's a few more examples in the notes, but look at this. If I'm trying to find C1, there's 2 lengths here that are both C1. For example, if I'm trying to work with this guy here, see if you can find a right triangle that uses that side. And so this, to me, is a right triangle. Now I know one side, I know the other side. I'm trying to solve for that third side. All right. So we can do that pretty easily. This is my hypotenuse. So when I write my equation, this is going to go all by itself on one side of the equal sign. So c1 squared, now this is c1, that's the name of the variable, c1 squared, and then I've got what are called the legs of my triangle, a squared plus b1 squared. And so, just kind of to run through the arithmetic real quick, a is 10, and we know 10 squared is 100. b1 is 15, we just did that. 15 squared is 225, equals c1 squared. 100 plus 225, 325. And of course, we know now how to undo the squared. It was using the square root. And so the square root of 325, now that we're talking about actual real measurements, it's probably not going to be a nice whole perfect square. I'm getting my calculator 18.03, which is probably more precision than we need for this application. But I'll leave it like that for the time being. Now, of course, the units are important here as well. Are we talking about inches, centimeters, miles, feet? And of course, here we're talking about centimeters. So make sure you include that in this type of assignment. Now, this is C1, so I'm going to round that to 18 when I write this down here. It's saying this is also C1, so that's also 18. Now it's asking for C2, which is this side here. I don't know this side, and I don't know this side. But I do know a lot of other sides. And so, for example, this height is consistent across my crane. And so this height is the same as this height, which is the same as this height. So that's got to be 10. And this bottom edge of this triangle, well, I don't know what that exact measurement is. I do know that the overall length from the end, the starting point here all the way to the end is 40 centimeters. And I know the distance from the starting point here to this other point on the bottom edge of my triangle is 30 centimeters. And if you took geometry, it's pretty easy. This is just a subtraction problem. So this is 40 centimeters minus 30 centimeters. This gives me 10 centimeters. And so now I know two sides of this right triangle. Piece of cake to find that third side. So give that a shot. If you need a little refresher, hopefully that has jogged your memory.